Hello and welcome back to Higher Maths Recurrence Relations. Today we are going to look at the limit of a sequence. So if we take a recurrence relation of the form un plus 1 equals aun plus b, with our value of a larger than 1 or smaller than negative 1, what we will find is that sequence just keeps on getting larger and larger and larger and larger and larger if our value of a is greater than 1. If our value of a is less than negative 1, it will just get smaller and smaller and smaller and smaller and smaller and smaller and smaller. Okay, why does that happen? Well, you can get your calculators out for this one, guys. Say we have un plus 1 equals 2un plus 3. So if we set that up the way we did in lesson 2, so we can just press the equals button a lot, what we'll find is it will get larger and larger and larger and larger. So press the buttons to check this yourselves. But why is it getting larger? Let's think about it. AUN, so we're doing 2UN, so we're doubling the previous number, which is going to make it larger. And then we're adding 3, which is going to make it larger. Then the next time round, we're going to double that previous number, which is going to make it even larger. Then add 3, which makes it larger still. And then to work out the next value of UN, again, we're going to double it and add 3. So there's nothing we are ever doing there that will make the number smaller, or will stop it from growing and growing and growing. Okay. Whereas some sequences converge, and by that I mean they tend to a limit. So they move towards a certain value. Okay, so if we notice in these two here, they are leveling off. So this is for values of a between 0 and 1. This is for values of a between negative 1 and 0. So if we just bounce back up a few pages to this question. So if you guys get your calculators out and just work through this one again. So we stopped at U5. If we kept on pressing equals after calculating U5, so I'd like you to do this, so please get your calculator out. So keep on pressing equals, we'll find it goes into the 9.8s, then the 9.9s. And if we keep on pressing equals, it'll go to the 9.99s and 9.999s. And eventually, if we press it enough times, it will move to a number that will be rounded to 10 on our calculator, because there's only so many decimal places. So we will get to 10, it will be rounded to 8 decimal places. It will come out as 10. Okay, so why does that happen? Well, in this case, we're only doing 60% of the previous number, then we're adding 4. Then we're doing 60% of the previous number and adding 4. So we're basically making it smaller, then adding 4, making it smaller, adding 4. And eventually we get to 10. What is 0.6 or 60% of 10? That is 6. Then we add 4, we get back to 10. And then we do 0.6 multiplied by 10, which is 6, and add 4, we get back to 10 again. Then we substitute 10 in, and over and over and over, which is why it settles at 10 at the very, very end. Okay. So if our value of a is between negative 1 and 1, there will be a limit. If a is greater than 1 or less than negative 1, there will not be a limit. Okay. So down on page 8 of our notes. So it is possible to work out this limit as well. So the sequence defined by un plus 1 equals aun plus b, with a larger than negative 1 but smaller than 1 tends to a limit L as n tends towards infinity, i.e. as n gets larger and larger and larger. So we noticed in the question from a few pages before with the limit of 10, we didn't need to press the equals button on a calculator an infinite amount of times to get it to 10. So this just basically means as n becomes larger and larger. Now to calculate the limit, it's quite easy to calculate. It's b over 1 minus a. So remember, this is our b term, this is our a term here. So b over 1 minus a. You do need to know that formula. It is not given to you in the exam. So let's have a look. The deer population in a forest is estimated to drop by 7.3% each year. Each year, 20 deer are introduced to the forest. The initial deer population is 200. Part A, how many deer will there be in the forest after 3 years? So to calculate that, we'll need to set up a recurrence relation. So a 7.3% decrease will leave 92.7% or 0.927 of the original amount. And then each year we're adding 20 deer into the forest. So there's our recurrence relation. Remember, we need our initial amount now, we need our U0. So then a little bit of number crunching using a calculator. U1 is 0.927 multiplied by U0 plus 20. And then calculate U2 and U3 in the same way. Okay, so nothing new there, but here's the new part, here's the limit part. What is the long-term effect on the population? It's essentially saying calculate the limit of the number of deer in the forest. So we must always state that a limit exists as -1 is less than our value of a, which is less than 1. That needs to be stated. Without that statement, we are dropping a mark, guaranteed. So a limit is b over 1 minus a, so 200 over 1 minus 0.927, which turns out as 273.97, so not quite enough to have 274 deer. So the number of deer in the forest will approach a limit of 273 deer. Okay, and that is the limit question done. So very common to get some sort of context there and to be asked to find the limit. Remember, very important, a limit only exists if the value of a is between -1 and 1. If the value of a is larger than 1 or less than -1, we could still substitute that value into here, but it would not calculate the limit of the sequence. Okay, a limit only exists for values of a between -1 and 1. So a slightly different limit question. A sequence is defined by this recurrence relation, and the first term is U0, so we're not even told what the first term is. We don't actually need it to answer the question, so we're not told it, but we're told that there is a first term, which is important. So given that the limit is 27, find the value of k. So I know the limit's 27, so the limit is always given by b over 1 minus a. So 27 is b, which is 2k, over 1 minus a. In this case, a is k. So from there, guys, cross multiply or multiply both sides by 1 minus k, which would leave us with 27 bracket 1 minus k equals 2k. Expand the bracket, collect all the k terms to the right hand side, divide through by 27, and there is our value of k. So exercise 15D, let's have a go at the questions. So finding the limit of a sequence, 15D, 1 A, C, F and G, and questions 2 to 8.